All right, so today we're going to look at some properties of definite integrals. We've looked at definite integrals a little bit. Um, so several things. First of all, the integral from a to b of f of x dx is equal to the opposite of the integral from b to a of f of x dx. So if there's ever a time when you have to, or you would like to, because it makes it easier to do the problem, switch the limits of integration, you can do so just by multiplying your result by a negative. Okay? The easiest one in the world, the integral from a to a of f of x dx is 0. Now, why is that?
Your limit is like 0.
Your limit is 0.
Like, if it's like you're not moving at all, it's just like.
So what does, at its most basic, what does a definite integral tell us? One word. 4 letters.
Area.
Thank you. And if you're starting at A and you're ending at A, how much area do you have?
None. 0.
None. Okay? So that's why. All right. So this next one, the integral from a to b of k times f of x dx is equal to k times the integral from a to b of f of x dx. Now, that should remind you of two things. First of all, when you're taking a derivative of a function, what do you do with any constant multiple? You keep it. Okay? You keep it. Now, the other thing that should remind you of is if I multiply some function by 3, what happens to the graph of that function?
It gets 3 times bigger.
3 times
What gets 3 times bigger?
which direction?
All of them. No. The value, the y.
Does the width of it change?
The length.
The height changes, right?
Yeah.
The heights are all 3 times bigger. Well, if you multiply the heights times 3, but leave the base alone, you change the area by a factor of 3, right? Okay? You can also split it up just like you do with derivatives. When we're doing derivatives, if we're adding or subtracting, we can do them individually. Same thing with integrals. All right, here's one that I want to spend a little bit of time on. The integral from a to b of f of x dx plus the integral from b to c of f of x dx is equal to the integral from a to c of f of x dx. And this is one where everybody is happy if you draw it a particular way. So if this is y is equal to f of x, and this is a, and we'll put b here, and we'll put c here. Everybody's happy with this, that the integral from a to b plus the integral from b to c is equal to the integral from a to c, because you're just adding those areas together. They're like, okay. Did it say that b had to be between a and c?
No.
No. Is it true if it's not?
Yeah.
Well, let's take a look. So, similar looking graph, y is equal to f of x. Let's put a here and b over here. Well, let's put c in the middle. So if I do the integral from a to b, I'm going to do these in different colors. The integral from a to b would be all of this area, right? The integral from b to c would be this area, but I'm going backwards from b to c, right? Therefore, it would be minus that part. Does that leave you with the integral from a to c?
Yeah.
Yes.
It's a different area.
Different than what?
Than the left graph, but I guess it's just a
Well, but here a, b, and c were a different order.
Yeah.
Yeah, if we change a, b, and c, we're going to change the area. But what I'm trying to point out is it works whether b is in between a and c or not. Okay, the order of these is not important. What is important is that this matches this. As long as those two are the same, it doesn't matter what these two are. Okay? All right. A pretty obvious idea, I think at least, but the minimum of f times b minus a, you're like, what the heck does that tell you? Well, the minimum of f, that's a y value, times b minus a, that's the width. This is an area. This is the area going from the lowest place on my graph of f is going to be less than the integral, which in turn will be less than the maximum value of f times b minus a, which will be another area, but from the highest point on my graph. The integral will be somewhere in between those two. Notice we put or equal to just in case f of x is a horizontal line or it's a constant function. Also, last but not least, if f of x is greater than or equal to g of x on the closed interval from a to b, then the integral from a to b of f of x dx has got to be greater than or equal to the integral from a to b of g of x dx, which makes sense. These heights are going to be higher than these heights, but it has the same width. So if you think about this in terms of area, it makes it pretty straightforward, I think. Let's take a look at this question.
It's 2.
Pardon?
1 is 2, right?
1 is 2. I have no idea. I haven't looked at it yet. So the integral from 4 to 1 of f of x dx will be the opposite, and I would suggest you make yourself write it out, the opposite of the integral from 1 to 4 of f of x dx. So that's the opposite of negative 2, which is indeed 2. All right, well, how are we going to get the integral from negative 1 to 4 of f of x dx?
Yo, the integral from 1 to 4, yeah, go from negative 1 to 1.
So what are we going to do with those?
Add them.
Add them together, yeah. It'll be the integral from negative 1 to 1 of f of x dx plus the integral from 1 to 4 of f of x dx. So that's 5 plus negative 2 is 3. All right, what about the integral from 0 to 1?
Would it be... Is it the one where you like rearrange them so you like go past and cut back some?
No? Okay. The most common wrong answer is for people to go, oh, it should be half of the integral from negative 1 to 1.
Well, how do we know?
Yeah, we don't know what this function does in between those two. Since we know nothing about what happens around 0, this is, notice it said if possible, not possible. We do not have enough information to calculate that.
That's unfortunate.
All right, so how about this one? The integral from negative 1 to 1 of 2f of x plus 3h of x. Well, that's going to be 2 times the integral from negative 1 to 1 of f of x dx plus 3 times the integral from negative 1 to 1 of h of x dx so it's 2 times 5 plus 3 times 7 is indeed 31. And of course, Irfan, you're showing all of your work on this, right?
Yeah.
All right, what about this next one? The integral from negative 1 to 1 of h of x plus 3.
You would just find the integral from negative 1 to 1 of h of x and add 3 to your answer?
No. And that is the most common wrong answer at the beginning.
Because it's shifting h of x up 3, right?
So the integral from negative 1 to 1 of h of x dx plus not 3, but the integral from negative 1 to 1 of 3 dx. Well, the integral from negative 1 to 1 of h of x dx, we know that is 5, right?
No, 7 is h of x.
Oh, h of x, thank you. Plus,
6.
yeah, why is it 6?
Because from negative 1 to 1, that's 2. 2 times 3 is 6.
So the answer is 13.
What if it had been minus 3?
Then this would have been minus 6.
But what if, like, you had the function and it was really close to your x-axis? When you went down, your function goes below the x-axis there.
Correct. So that
So you would still take.
the integral is going to report that as negative. I'm not looking for area here. I'm looking for what's the value of the integral. If I'm looking for a specific area, I have to take into account positive, where the integral is going to count things as positive and where the integral is going to count things as negative. All right, what about this last one? The integral from negative 2 to 2 of h of x dx.
It's not possible.
Yeah, it's not possible. We don't know anything about what happens at 2 for anything. What do you think might be a potential wrong answer that people might give?
14.
14. Okay? All right, page 2.
Or moving so fast.
Not that fast.
Alright.
All right. So if we know the area of a rectangle and its base, we can find its height, right? Lance, you with this? The height would be the area divided by the base. Correct? Okay. Well, if the top of the rectangle, and I put rectangle in quotes there, is a curve, and we divide the area by the base, we get the average height of the figure. So let's think about that for just a second. Basically, what we would be doing is going, okay, and that's not quite right, but this area would fill in that area, and that this would be the average height from there to there. That makes sense? Well, if the curve is all above the x-axis, we know how to find the area, right? We just take the integral. So if we take the integral, which is the area, and divide by the width, which is b minus a, we're going to get the average value of the function. And you can't think of it as area if this is below the axis, but it turns out it works if this is below the axis, because it gives you, if this integral is negative, well, then the average value of the function should be negative also. Okay, and if f is continuous on the interval from a to b, then there's got to be some point c in the closed interval from a to b such that the average value of f is equal to f of c.
This is very familiar.
Yeah, it should be. Okay, let's take a look at a problem that asks you about that. Find the average value of f of x is equal to 7 minus x squared plus x on the interval from 0 to 3. Where on the interval does f take on this value? Okay. So the average value should be equal to the integral from 0 to 3 of 7 minus x squared plus x all dx over 3 minus 0. Since we don't know how to do this with this x squared term in here yet, if it had just been the 7 and the x, that would have been some sort of a linear graph and we could have used area. We're going to grab our calculators. That's 5.5.
My calculator gave its answer as a fraction. That's weird.
Well, do you have it set to auto or do you have it set to decimal?
Auto.
That's why I gave you a fraction. That's okay.
Where do you set auto or fraction
Mode.
I think it's right at the very beginning, isn't it?
Now you have math printed classical. I don't see auto anywhere actually.
Oh, answer auto or decimal.
Let's see it.
Interestingly enough, mine's on auto also,
Mine is 2.
and it gave me a decimal. Is yours the Python one?
Yeah. Also updated my calculator software from the website recently.
Did you use the TI-84 or the
TI-84C. Yeah. I can only use the TI-84 plus C Python software.
Did you use like Texas Instruments software? You get some
Texas
ghetto
Instruments.
stuff from the Blackbook.
So now we want to find where on this interval does f take on this value? How are we going to do that?
Solve for x.
How?
Set it equal to 0.
How?
We moved the 5.5 over.
With a truck?
Yeah.
Anytime someone talks about moving,
Subtract 5.5 from both sides.
yes, so this would be 1.5 minus x squared plus x is equal to 0. We'll graph that and find the zeros.
I just found my calculator
Do we
here.
have to set the window to 0 to 3?
We will. And that's a good thing to always think about. What is the appropriate viewing window? And I'm looking for zeros. Do I need my y to go from negative 10 to 10?
If you want to.
No. You can leave it if you like, but I just set it from negative 1 to 1. And there it is, somewhere between 1 and 2.
1.822.
One.
Okay? Questions about that? Yes.
Will this be on the quiz on Wednesday?
I don't believe so. Let's see. Wednesday's quiz. 6-3.
Well, this is
Oh, yep. This is 6-3. Yep.
So what we do tomorrow will not be
Correct. Yeah, I never do something where you learn it one day and quiz on it the next. But sometimes, the day after that. All right. So, consider, for example, a plane flying at a constant ground speed of 120 miles per hour from noon until 6 p.m. Boy, I hope he's got autopilot. What does the integral from 1 to 4 of 120 dt tell us?
that from
how far it traveled. From
1 to 4, he was traveling at 120. So the integral, the displacement,
So that would be the
or distance covered.
from
From 1 to 4.
from 1 to what's 1 to 4
what's
from
noon? What time is noon?
Are we counting noon as 1, or are we counting 1 o'clock as 1? I mean, it doesn't really matter.
I think it does.
Mathematicians be like.
But if you count,
Well, in terms of what this tells us.
oh yeah.
So the integral from 1 to 4 of 120 dt is you can either use displacement or you can say the distance traveled.
Isn't there a difference between distance and displacement? There is.
Distance, in this particular case, since it's going in the same direction all the time, they're the same. By the plane in miles from 1 p.m. to 4 p.m. Notice it didn't ask you to calculate it. It just said, what is it? Well, we could calculate it pretty easily. What would it be?
480.
Try again.
480 miles.
Try again.
360.
360 miles.
Still learning to count.
All right, so next part. If S of t is the position of the plane at any time t between 0 and 6, then its velocity is S prime of t is equal to V of t, right? So what does the integral from 1 to 4 of S prime of t tell us?
The speed at which the aircraft was traveling in miles per hour from 1 mile.
We're taking the integral of the velocity. Isn't that exactly what we did here? Yeah. So this would be the displacement of the plane.
What's this?
That makes more sense.
From time t equals 1 to t equals 4. And the displacement would be s of 4 minus s at 1, right? That's how you find displacement.
So if you'd done the integral of the position, what would you have gotten?
The integral of the position, I have the slightest idea what that actually tells you. At least not in the real world. So, if we interpret the integrand as a rate of change, f of t, with antiderivative capital F of t, then the integral from a to b of f of t dt is capital F of b minus capital F of a. So, let's do this using an antiderivative. What can I take the derivative of and get sine?
Negative cosine.
Right, so this would be negative cosine at pi minus negative cosine at 0. Cosine at pi is negative 1, so that's 1, plus cosine at 0 is 1, that's 2. And we'll work more with antiderivatives. Y'all have a great day.